Hi everybody, we're taking a look at page 843, technically 844 is where these problems came from. We were talking about permutations, and this might actually lead into combinations for some of these problems, but I'm glad we had a chance to think about them. So let's see, problem 27 is a direct application of the formula. What formula am I talking about? P of n comma r is equal to n factorial over n minus r factorial. All right, so n is 10 in this case, so this is just going to be p of 10, 7 is going to equal 10 factorial over 10 minus 7 factorial, and that's in parentheses, which is important. Let me show you this cool little trick. So 10 minus 7 is going to be 3. It's not that helpful in this case. 10 times 9 times 8 times 7 times 6 times 5 times 4 times. Because this bottom is going to be 3, I'll actually write this as 3 factorial here over 3 factorial, right? Because 4 times 3 times 2 times 1, 3 times 2 times 1 is 3 factorial, so I can just write it that way. And sometimes if it was like going to be 7 factorial or something, like I would have just written, 7 factorial here, 7 factorial there, and then cancel, cancel, and it can sometimes save you a lot of work. In this case, though, it doesn't save us that much, but it kind of can work as a cool little trick. And then I would have to multiply all this out. Let's see, 5 times 4 is 20, times 10 is 200, and multiply, multiply, multiply. I believe we get 604,800, maybe? Let's see what I get. That's what the book says I'm supposed to get. 10 times 9 times 8 times 7 times 6 times 5 times 4. Yeah, that's what I got. 604. Ah, okay. Yep. All right. Well, that's an easy fix. Isn't that wonderful? Like sometimes, right? Obviously, it's frustrating getting every problem wrong, but when it's an easy tweak, you're like, okay, I can remember that. Problem solved. So yeah, so that's not that bad. Not too shabby. Right. So let's look at this next problem and maybe have a philosophical pizza conversation here. And that's where some of these problems get interesting is we've got to figure out whether or not order matters. So it says, problem 40, a pizza shop has 14 different toppings from which to choose. How many different 4-topping pizzas can be made? Okay, so my question for you is pepperoni, mushroom, Hamburg, extra cheese, is that a different pizza for you than Hamburg, mushroom, pepperoni, extra cheese? I mean, I know of some people who eat their pizza slices upside down so that the cheesy topping side touches their tongue first rather than the crust, and you actually get a different, slightly different tasting pizza.
Are you for real?
I am for real. Yeah.
I know, yeah.
No. Like, but think about it. Your tongue is like just touching all crust, and you don't get all the deliciousness until you start chewing it.
Well, I mean, you have to chew it anyway.
Right. But you're starting with delicious flavor and then chewing and mixing it. Yeah. It would require some complexity. I don't know if they get like a pizza slice like this and then just like do like this weird like fold like that. I don't know. And I don't know what they do. I don't know. But somehow some people try eating their pizza upside down. I have no idea. I'm not sure. But anyways, so the point is that order doesn't really matter for this. And I think you guys agree, right? Like, it's kind of all getting jumbled together, right? So if I did this as a permutation, all right? Permutation, I'm of 14 toppings choosing 4, right? If I did this as a permutation where order did matter, I would have had 14 factorial over 14 minus 4 factorial, which would equal 14 times 13 times 12 times 11 times 10 factorial. And you might have realized I'm choosing that wisely, where to truncate it, so to speak. 14 minus 4 in the bottom is 10, and hey, that's 10 factorial. What? So the 10 facty cancels out. and I would get, this is probably the number you guys got last night, since I only taught you about permutations, not combinations, is 24,024. That's actually a palindrome, that number. Okay. But if you multiply just the top up there, or, well, did you have the factorial piece there? Okay, so that would have done it. Now, my question is, how many extra varieties of pizza did I count here? How many overlap did I count? And now this is just the number of ways to have the order matter. So if I want to figure out how many extra pizzas are included here, what do I have to divide by? Well, I considered, right, pepperoni, mushroom, sausage, and Hamburg to be different than mushroom, pepperoni, sausage, and Hamburg, right? And that's different than mushroom, sausage, pepperoni, Hamburg, which is different than mushroom, sausage, Hamburg, pepperoni. And this could just keep going. And my question is, how many ways could I have arranged the same 4 toppings? 4 ways. So how many ways can you arrange 4 toppings? 4 tops, 4 ways, right? And I've heard some students suggesting it. They're saying that the number of ways this could happen, well, this is the same as permutation 4-4, right? Which is 4 factorial. So there's 4 factorial too many pizzas, but a magnitude of that. I'm multiplying by 4 factorial too many, right? Because not only did it happen for this combination, but it also would have happened for, right, bacon, pineapple, fresh tomatoes. Man, I'm really, I'm having a hard time thinking of things. And other ingredient, I don't know, peppers, right? And so every time I'm having 4 factorial too many. So it turns out this number is big by a factor of 4 factorial. So what I could actually do to eliminate the order repetition is take that number and divide by it. Yeah, think about that. So I have to eliminate all of those extra situations that we weren't caring about. So divide by, and 4 factorial, 4 times 3 times 2, is that what, 24. And I get, behold, 1,001, another palindromatic number, which is the actual number of varieties of pizza that can be made, right? So this pizza place, right, if they had on their advertisement, with our toppings at our pizza place, you can have 24,000 kinds of pizza with 4 toppings, right? I'd be like, well, not really, because these are kind of all the same-ish to me, right? These are all impsh, right? That's what I have to say about that. Impsh. I don't think so. So we had to eliminate the duplicates, at least from the perspective of these pizzas. All right, and we're actually going to have a shortcut way to do that later today when we talk about combinations.
How did you know there were 4 pizzas?
Well, there are 4 topping pizzas. So once I have chosen my 4 toppings, I realized that, okay, I also had counted every arrangement of those 4 toppings. So that's why I had that many extra. So let's see, 42. How many different 12-member juries can be formed from a group of 18? So, question, does order matter? Well, yeah, I would say technically no. When I served on a jury last year, we actually had 108 people that were in the room, and they selected multiple 12-member juries. They actually selected, I think, 14-member juries, just to reduce the possibility of what if a juror misses, it'd be a shame to have to redo the whole trial because, one of our jurors just got in a car accident and, can't make it. They're at the hospital, right? And then, you have to redo the whole trial. So they had 2 extra just for the possibility of, okay, we'll just dismiss 2 of them at the end, whatever. But the point was that once you were on the jury, I did get a number. I was juror number 5 or whatever. but that number actually didn't matter. I didn't have any extra authority. And they did actually at one point select a head juror, but they didn't have any extra authority either, other than the fact that they would like say whatever like the verdict was. So the point is order doesn't really matter here. All right. So some of these are definitely, culturally specific problems. You'd have to kind of know the situation. You'd have to understand enough about juries to know whether or not order mattered, right? Just like when we do problems regarding poker and cards, right? You'd have to kind of be like, well, if I don't know anything about poker, I don't know whether order matters or not, right? So you'd kind of have some experience or conceptual knowledge there. So what if order did matter? You guys probably last night would have done a permutation of 8, 12, which that would have been answering the question, how many different ways can I rank 12 people from 18? All right, or where if I had 12 different positions on this cabinet or this jury, like they all had different roles, right? So this would have been 18 factorial over 18 minus 12 factorial, right? Or that's 18 times 17 times 16 times 15 times blah, blah, blah. That's 9 times 8 times 7. 18 minus 12 down here is 6 factorial, right? So the 7 times 6 factorial, I'll just throw the 6 factorial over here because I ran out of room. And that cancels out, right? Man, wouldn't it be great if there was a way I could just plug this in a calculator and have it give me the answer? Maybe I'll tell you that someday. So equals, and then when you multiply all that, someone said how many trillion?
Well, I got 8 trillion.
Okay, yeah, I got 8, 9, 8, 8, 9.
2.
Yeah, 2, 1, 8, 5. Let's see. 7, 0, 2. And it was 8 point this times e to the 12th, so I'd have to shift that over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Oh, your calculator was more accurate than mine, I'm guessing? Had more significant digits? Sig figs? Bam. Okay. So, and that is too many. All right? That's more than there actually are. Because this was considering order mattering. So, what we need to consider is I have, right, juror 1, juror 2, juror 3, ... all the way to juror 11, juror 12. And we counted that different than, yeah, in this case, the permutation was counted different than juror 2, juror 1, juror 3, all the way to juror 11, juror 12, right? So the question is, how many extra did we count? Now, that was a sad-looking bracket. Right, how many ways can I arrange? How many 12-12 arrangements? Right, so that would just be P1212 or 12 factorial, right? So that means this number is bigger by a factor of 12 factorial. So I'd actually have to divide it through by 12 factorial. And I'll show you some cool shortcut tricks later. Like for instance, if here I knew that a 12 factorial was going to be in the denominator, then I would have, instead of going down to 6, I would have just gone down to 12 factorial, canceled that out, and then figured out where to cancel the 6 factorial out with the rest of it. So dividing that by 12 factorial, yikes, divided by 12 factorial, and I got 18,564. Hopefully that's right. Anybody? No? What was the book's answer? Yeah, that's the book's answer. Excellent. Whew. All right. So, I wouldn't be concerned if you guys, were doing the permutation because I didn't show you combos yet, which is what we're talking about today. So, perfect opportunity to talk about order mattering. I don't know. I can't think of a pizza where the extra cheese goes. If extra cheese is considered a topping, like extra cheese goes on top of the other ingredients in my mind. But anyways. All right, thanks for watching, friends. Bye-bye.